Let's resume back our discussion, and we have discussed and or, and now we will look at two other bitwise operators, which is not and XOR. In the not case, whatever bits you have, just do one's complement. That means if bit is 0, make it 1. If bit is 1, make it 0. And that is what basically the complement is. And same is true, XOR is different. So if we look at truth table, if my bit is, let's say 1, my one bit is 1, other bit is 0, my answer would be 1. This is XOR. I'm doing a XOR. A bit is 1, second bit is 1, XOR would give me 0. If this is 0, this is 1, this again would be 1. And if both bits are 0, XOR would give me 0. That basically means both bits are same. Doing an XOR gives you 0. If both bits are different, like in this case they are different, the answer is 1. Given that case, if I were to do an XOR is an operator which is represented by up arrow, which is what have been shown here. Up arrow is the operator. So if I were to do XOR of, let's say 14, XOR 10, what would my answer be? Can you work out and tell me what would the answer be for XOR of 14 and 10? What would be the bit representation of 14? Sorry, are you seeing my screen or no? Doesn't look like. I'm not sharing my screen. Looks like that to me.
Yes, no, sir, it's not shared.
Not shared.
I started, which told me at least. Sorry for that. I thought I had done that part. So let me repeat. Now is it visible?
Yes, sir.
So when I say do an XOR, if both bits are same, answer would be 0. If both bits are 1, both bits are different, answer would be 1. So two possibilities, let's take bit 1. My bit 1 could be 1, second bit could be 0, bit 1 could be 1, second bit could be 1, bit 1 could be 0, second bit could be 0, bit 1 could be 0, second bit could be 1. And if I were to do an XOR operation, this is what I call XOR.
Is it 4?
Yeah, I'll come to that, yes. So if you look at, because it was not visible, so I'm repeating that. So XOR is, if you look at the first one, this is 0 and 1. This should be 1 because both bits are different. This both are 0. So XOR would be 0. Both bits are 1. So XOR would be 0 again. And here 2 bits are different. So XOR would be 1 again. Now the question I ask is, given 14, if I do 14 in decimal XOR with 10, answer, as just pointed out, is 4. Why? Because 14 in bits pattern would be 1, 1, 1, 0. This is 14. 10 in binary would be 1, 0, 1, 0. This is 10. If I were to do a bitwise OR, 0 and 0 gives me 0. 1 and 1 gives me 0 because same bit. 1 and 0 are different, so I get 1. 1 and 1 they are same, I get 0. So answer would be 4. So you can run the program and see that. Let's see if I can run the program. (14, 10), and you'll basically see answer would be 4. You can see answer is 4. If I were to do, let's say, XOR of 12, XOR 12, what is the answer I would get? Any thoughts?
Zero.
0. So any number XORing itself, because the both bits would be the same, you will always get 0. You don't even need to convert anything. Any number XORing with itself will always going to give you 0. As you can see that. So all I'm trying to say is you practice. Only challenge could be when you do a negative complement, that means whatever bit 1 is there, it will become 0. Whatever 0 is there becomes 1. Now let's write a simple, let's say I write, and that is represented by tilde sign. Let's say this is negation of 8. And if you run this, you will see the answer a negative number, -9. And you thought why that is happening. I'm doing negation of 8. So let's say I were to define int x, comma y, let's say x is equal to 10. I say y is equal to complement of x, print y. What do we get? Any clue why this is happening? Complement of 10, if you print, it becomes -11. It goes back to your 2's complement because all the negative numbers are written in 2's complement 4. So if you were to look at, let's say 8, positive 8 in binary would be, if I were to write positive 8 in binary, integer is 32 bits, so it will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0, sorry, 1, 0, 0. This is 8. If I were to do negative 8, complement of 8, so complement of 8, which is tilde sign, every bit here would become 0, would become 1, 1 becomes 0. So this becomes 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1. Now, 2's complement are the negative numbers. The most significant bit, which is this, is 1. That means number is negative. And because number is negative, that's what we basically get treated as a number. And if we look at the negative number, this would be equal to -9. That's what you need to. So practice with your 2's complement numbers. When you do complement, you are doing only one signs complement, but number is treated as negative number. And in C implements negative numbers using 2's complement, not 1's complement. Hence, it becomes a -9 in complement. And that is what I would like you to talk about. Next, we look at shift right operator, and we already discussed and or. So if we look at, let's look at the number 8, and we write in 8 bits. If you look at the number 8, it is 0, 0, 0, 0, 1, 0, 0, 0. If I do shift left by 1, that means all the bits are shifted left by 1. So this bit comes here, this comes here, this comes here, this comes here, and at the end we basically get the 0. When you shift left, right must be filled up with 0, so this new number would become, so if you look at, this becomes 0, 0, 0, 0, and this one comes here. And now this number in decimal is 16. So if you were to print this effectively too, because you are shifting the binary by binary number, any shift left is effective as good as multiplying by 2. Shift left 2 times, multiply by 4. Shift left 3 times, multiply by 8, and so on and so forth. By the same logic, when you do shift right, if I were to do shift right of this number, then you see this number would go shift 1 right, and whatever the sign bit is, it will percolate there. If it is 0, it will remain 0. If it is 1, will get filling by the 1 because of negative number. And hence, so shift right becomes division by 2, shift left becomes multiply by 2, and so on and so forth. And that's what happens. We look at the octal representation, that if the first digit is 0, so when I were to write a number 0, 1, 2, 3, if this is the number, what would this be in decimal? This octal representation, that means using 8 values, 0 to 7. So if you look at, this would correspond to 8 power 0, this corresponds to 8 power 1, this corresponds to 8 power 2, this corresponds to 8 power 3. If you were to write this 0, 1, 2, 3, value would be 8 power 2 into 1 is 64. 8 into 2 plus 16 plus 3, so this would be 83. You have to be comfortable with bit conversion and be comfortable with how do we use that. Another US specific operator, which is what we call as comma operator. Essentially, this enables some kind of pre-processing and the results are discarded. So you were to look at the two numbers when I'm saying x is equal to y star equal to 2 and y plus 1. This is computed, evaluated, and discarded, and x should be assigned this value. There could be multiple comma operators. Make sure the comma operators things are in parentheses. So what this happens is y gets multiplied by 2. So y becomes 20 here. And then 20 plus 1 is 21. Hence, x would be assigned value as 21. So you have to look at, understand, so comma operator means evaluate and discard, use the values. And this probably used in the for loop or while loop. Sometimes we use that, you see those uses there for comma operator. Normally, it's recommended not to use it. Only in specific cases, we use the comma operator, but we generally do not use it. Well, the complex operator is what we call is conditional operator. That is where it's called tertiary operator as well, because this operator has three operands. Syntax is expression 1, question mark, expression 2, and expression 3. And typically, this expression 1 is a Boolean condition, true and false. So if this expression evaluates to true, then x would be assigned. So if this expression happens to be true, then x should be assigned the value of second expression. If expression happens to be false, then x would be assigned the value of expression 3. And that's typically what would happen. So we have to look at, if you want to assign, let's say, max of the two numbers, then we can simply say, let's say we have three numbers, A, B, and C. We have two numbers, A and B, and we want to find the max. So I can simply write max is equal to, first is A greater than B. If this is true, assign A, else assign B, semicolon. So this is the condition. If this evaluates to true, the max would be assigned the value A. If this condition is false, then max would be assigned the value B. And this is what is called conditional operator or tertiary operator. So essentially, this part, which is showing the max operator, it is a simple form of, rather than writing, normally we write to find a max, we say if A greater than B, we say max is equal to A, else we write max is equal to B. So this all if blocks kind of become equivalent to the max block, and we study more in detail after a few minutes the conditions. Other thing, quite often there's something called a size of operator, and there's a misconception about the size of operator. Size of is a compile time operator, is not a runtime operator. It basically tells what is the number of memory bytes a particular variable holds. The size of operator does not lead to any computation. Like in this case, we are given x is equal to 10, y is equal to 20, and I'm saying x is equal to size of plus y. So normally you would think that first y would be incremented and then we'll use a size of. But size of is a compile time operator. There are specific cases when you deal with arrays that we do it runtime. But in general, when the type is very well known, it is the compile time operator. We know that y is an integer because y is an integer. Integer takes 4 bytes or 8 bytes. So it will not evaluate this, and it will be basically 4 bytes for the integer. So let's quickly run and show the code so that you can understand what happens. Let's say x is equal to 10. I would say int y, and then I say y is equal to size of plus plus x, and I can say print of percentage d x comma y. Quite often when you look at, you'll ask the students, answer they will give is x should be printed as 11 and y would be printed as size of it is 4 bytes. But in this case, because this is size of this compile time operator, this never is not a function, so this never gets incremented, it's only type is used. And if you run it, you'll basically see the values x of 10 and y would be, where is my mistake? Oh, sorry, there's a double quote missing here. So this was a mistake, which is fine. Let's run it. So you can see x is still 10, x is not incremented, and integer is 4 bytes. But if I were to do size of plus plus x, let's say plus, what do I say? 1UL, I'm doing a long number, 1L is a long integer. So it gets converted, we get into implicit conversion, and size of would basically comes at the size of the long part of it and not the integer part of it. So I can look at, I can declare as a long variable, and whatever that size of long would be, it will display me that, which has become 8, because long is taken as 8 bytes, and x doesn't get evaluated. So in size of things never get evaluated. If it is single operator, I believe don't have to put parentheses. Even this should be fine as an operator, and that should also would work. So there is a very specific case that size of gets evaluated at runtime. When we deal with dynamic arrays or what is called variable length arrays, then it behaves differently. But for all other purposes, size of is compile time determines, and there is no code generated. Hence, this expression is not evaluated at runtime. Is whatever you do inside, it does not make a difference. So understand that specific part. We discussed that part. Next I saw it is what is called a type conversion. Things automatically get converted. If it is a char, other is int, both char and sort get converted to int. If assignment is unsigned int, they converted to unsigned int. They're converted to long int, unsigned long int, typo error there. And so on, so forth. Sometimes you can do, so if I'm using it, if I'm doing a, let's say int x, so if my variable happens to be, let's say char c it is automatically converted to int, and that's what it will happen. And same is true for sort, and so on, so forth. Sometimes you want to do specific type conversion, and so if I were to say int ff, it will basically discard the decimal part, and you'll basically get only the integer part of it. It should actually be like this. Again, there's an error there. So that means discard the decimal part, keep it on integer part, and then what the conversion would happen. Given that the scenario that automatic conversion happens, let me show you something and seek your input and see what is that you like to talk about in the following. Can you tell me what would the values be for these four expression I have written? That will tell you the idea of how the conversion happens. Okay, I think there's an order part here. Let me complete that. Then I come to here. Otherwise, we'll have a little confusion there. So let me complete the order part. Look at the operators. We always have a precedence, which is the multiplication division. Multiplication division higher precedence. So if I were to do 3 plus 4 star 5, multiplication higher precedence. So first 4 star 5 would be evaluated, which would become 20, and then it becomes 3 added, it becomes 23. So if there are arithmetic operators like logical operators, so you would see A plus B would be evaluated first, C plus D will be evaluated then, and then you will do the comparison. So there's a whole operator precedence, but most will be dealing with plus and minus, which is lower precedence, then the multiplication division, then arithmetic operator high precedence, then logical and bitwise operators have the lowest precedence. So given that, if we look at these two numbers, 3 plus 5 star 6 by 4 versus 3 plus 5 by 4 star 6, the answers would be different. And then again, there is also called associativity. Do I evaluate from right to left? Do I evaluate left to right? All these automatic computations are performed left to right with their precedences, and that's where the answer would be. Given that, can you somebody tell me what would the answer be? What would the answer for 3 plus 5 star 6 by 4 and 3 plus 5 by 4 star 6 would be? Let me first get the answer. What the answer of 5 star 6 by 4 versus 5 star 4 by 6 would be? I'm asking this, the difference between this. 5 star 6 by 4 versus 5 by 4 star 6. And would like to answer? Aditya? When I'm asking, you have to probably give me your yes, no answers. Otherwise, I'll consider you absent. Aditi? People who don't
Please
respond.
show the question once.
What I've been seeing, so what were you doing there? That you are not in the class. I repeated sorry 3-4 times. You don't see the question. I'm asking difference between 5 star 6 by 4 versus 5 by 4 star 6. Aditi?
Yes, sir.
What is the answer? Simple mathematics.
First one is 7, second one is 6.
No, I'm saying about 5 start 6 by 4. Okay, first one is 7. And second one is why? Can you explain why?
Sir, BODMAS rule.
Tell me now why. How did you get that? How did you get 7 and 6? Okay, what would happen in this case? Let's have to change this.
When multiplication and division, both of them come in the same expression, you do them from left to right. You just solve them in the
which
order
is
they've
fine.
given.
Yeah. So my question is now, what would this be? 4/5 multiplied by 6. What the answer would be? Four divided by into 6. Quick.
Sir, 4.
Why?
Is
Can
it
you explain
0?
me why? Tell me why. Doesn't matter what the answer is. Can you justify me what is the why do you think what is the thought process is? Yeah, who said
4
Sir,
0?
because of
slash 5
BODMAS
is
rule.
No, the Shivani said 4 or 0? Yes, Shivani. Should it be 4 and 0? Arjun, what you were saying, 0 or 4?
sir,
4.
it's
Yeah. Go ahead. This left to right is 4 by 5. This is the integer division. And
will give
because
you
the
0.
integer division, this will give you 0. And because this is 0, multiply by 6, the answer would be 0. 4. Here it is 30 divided by integer division 4, which is 7. Any doubts about this? This 4 by 5 integer division gives me 0. 0 multiplied by 6 is 0, and hence this would be 0. Here 5 into 6, 5 into 6 gives me 30. 30 divided by 4 integer division gives me 7. Any doubts? So when you write program, make sure that you understand what you are dealing with. Let's look at the next part. Now can you tell me answers of these 4? What would you print it? What the output the first one would be?
Ten.
Yeah, what the answer? Please tell your name so that
10.
I can
First one 10.
recognize an answer. Why 10? This is 4 by 5 integer division gives you 0. 0 multiplied by 6, 0. 3 plus 0, it becomes 3. So this would be 3. What about this?
7.
7. Because 4 into 6 is 24, into division by 5, it basically gives you 4, 3 plus 4 is 7. But look, whatever the numbers are, I'm trying to interpret as floating point. So unless you know the bitwise representation, your answer is going to be completely haywire. You cannot depend upon that. In this case, I'm converting this float. So if I were to do this whole thing is evaluated, then converting into float, so it doesn't make a difference. But if I were to do the following, I'm typecasting float to 4, and then you would see, look at the answers. Here now you look at this number, especially the last one. I'm doing 4.0. Because it is 4.0, number has become floating point. So everything would be taken as a floating point. And even here, if I were to do, everything would become a floating point, and that is when you'll get those answers. Some syntaxes. Argument types of problematic case, which is fine. So let me remove that part. But this is
Sir, there is a close parenthesis in the third line, in the third printf statement.
third printf. This is fine. This is fine. No.
No, the middle one. After 4/5 into 6, you've put a bracket.
Oh, yeah. This is the problem. See what is happening here. Because I'm typecasting 4 to float, 4 expressions become float, and then you get right value. So everything converted to decimal point. So it is 4.0 into 5, which is 20 divided by 5. So it is 0.8 into 6. It becomes floating point, which is 4.8 plus 3.0 becomes 4.7. But in this case here, since these are precedence computed first, this is taken as integer evaluation. So this gives you only 4, and 4 is added to 3, you get 7, and that's the answer, you get 7 here. So you have to be very careful when doing the implicit conversion, how does the float and other thing happens, and that's the point I'm trying to basically indicate. Be aware of precedences, look at it, and even in the logical comparison, you might have different order. For example, I can probably say, if you were to look at, let me say, right, x is equal to 1 is less than 1, less than 1. If I were to print x, so this is a Boolean operation. I'm saying 1 is less than 1 less than x, and this is left to right association. Now, if you look at, first is we evaluate 1 is less than 1. 1 is not less than 1, so this is false, and false becomes 0. And now because 0 is less than 1, which is true, so x gets a value 1. If we do that, x gets the value 1. If I were to write y is 1 greater than 1, greater than 1, what would the value of y be? If you look at 1 is greater than 1,
0
is false, is false. So this is 0, and 0 greater than 1 is false. So that's so different. Now, if I were to change this, I have to write x is equal to 0 is, let me what would say, let me take a different number. 2 less than 2 less than 2, and 2 greater than 2 greater than 2. What is that the answers would be? Or look at 2 less than 2 is false, and 0 less than 2 is true. So answer would be 1. This is false. This gives you 0. Greater than 2, which is false, this would be 0. So you have to look at accordingly. The answers would vary depending upon. This is called left to right association. There are some specific cases of right to left associations, complex operator, and we'll deal with them when that comes to. Right now, those will come with increment operator along with pointers. And so when you deal with pointers, we'll explain the right to left association with specific cases, otherwise no. So we looked at constant and literals, we looked at the operators, we looked at the type conversion, and so on and so forth. So essentially what we had done, we have completed our operation part of it. So this we had done. So we looked at the operators, precedences, deal with it. So write simple program, work with it, do bitwise OR operation and other things. And tomorrow we'll look at the conditional cases, that is if, and when do we use the if, nested if, switch statement, control statement, and that's what we'll study tomorrow. Let me know, otherwise we can disconnect. If no questions,